Hi everyone, so today we're going to be looking at a very interesting topic. We're going to be considering quadratic expression. So we are going to be treating everything that we need to know basically about this topic, what it looks like, what a quadratic expression looks like, and how to identify one. And also we're going to be looking at how it is written, the general form in which a quadratic expression is usually written. We'll also look at some examples, yes, and we'll do one or two factorization as regards this topic. So first of all, what is a quadratic expression? So a quadratic expression comes in the general form a x squared plus bx plus c. Yes, where a cannot be equals to 0. A and B, A, B and C are constants, but x is an unknown variable. Now, how can this come? We can have some examples. We can have 2x squared plus x plus 1. Yes, this is a quadratic expression. Yes, this is a quadratic expression. Now, if you compare this expression with this expression, you realize that they're actually the same thing, because in this expression, a is 2, b is 1, c is plus 1. Now we can also have x squared minus 11x plus 30. Now this is another quadratic expression. Now the coefficient of x squared here is 1, so we can say that a here is 1. The coefficient of x here is minus 11, so we can say that b here is minus 11. The constant is 30, so we can say c is 30. Now we can also have it in this form: 3y squared minus 11y minus 4. Again, the coefficient of y squared is 3. Comparing this expression with this expression, you see that a is 3, b here is minus 11, and c is minus 4. Now we can also have 6x squared plus 11x minus 35. And then we can also have minus x squared plus 6x plus 18. And we can also have 20x squared minus 15x minus 10. Another example of a quadratic expression can be minus 4x squared minus 7x plus 12. And then we can also have x squared minus 9. Now these are the various forms in which we can have quadratic expression. Looking at all these examples, one thing is constant. There is an a, there is a b, and then there is a c. Let's take this expression for instance. You see that my a here, if I compare this expression with the general form here, you see that my a here is minus 1, because that is the coefficient of x squared. It's like saying what is standing beside x squared, it is minus 1. So a here is minus 1, b here is plus 6. What is standing beside x? It is plus 6. So b, as shown here, is plus 6 here. What is here? The constant here without any x variable is plus 18. So we can say that c is plus 18. Now these are the various forms that we can have quadratic expressions. So the next thing we are going to be looking at is how to factorize a quadratic expression. Alright, so we have an example here, which is to factorize x squared plus 7x plus 10. Now the first thing to do when you are given a question like this is actually to identify your constants. So we have x squared plus 7x plus 10. So now if we compare what we have with the general form of a quadratic expression, which is ax squared plus bx plus c, we will see that if we compare this with what we have here, or what we're given to factorize, we'll see that our a is equals to 1 because there's an invisible 1 here. Yes, then our b is equals to 7 plus 7, and our c is equals to plus 10. Of course, a is plus 1 there. Now after identifying what our constants are, a, b, and c, we'll go ahead to solve. Now we have x squared plus 7x plus 10. Now we are asked to factorize, which means to group. The first thing we want to do in factorizing, the first thing we like to do is to replace our constant b. We want to find two numbers that we can use to replace what we have as b here. Now those two numbers are such that when we multiply them, okay, we should have the product of a and c, right? And likewise, when we add them, we should have b. Now what is the product of a and c? A is 1, c is plus 10. So the product is plus 10, which is 1 times plus 10. Now our b here is plus 7, right? So we are looking for two numbers that we can multiply together to give us plus 10, and that we can add to give us plus 7. The first thing that comes to mind is, what are the multiples of 10? We know that 1 and 10 are the multiples of 10. We also know that 2 and 5 are the multiples of 10. Now, can we get plus 7? Is there a way we can add these two numbers to give us plus 7? No. There's obviously no way we can get plus 7 from 1 and 10. So this option is actually out of it, right? The next option we have that we can consider is 2 and 5. Of course, we see that there's a way we can add 2 to 5 to get 7. How can we do that? We see that if it's plus 2 and plus 5, if we add plus 2 and plus 5, we're going to get 7. Then we bring it here. Is it going to give us, if we multiply plus 2 and plus 5, are we also going to get plus 10? Yes. If we multiply plus 2 times plus 5, we're going to get plus 10. And of course, if we add plus 2 to plus 5, we are going to get plus 7. So the two numbers we are looking at, or the two numbers we are looking for, are plus 2 and plus 5. So we're going to replace plus 7 here with plus 2 and plus 5. Just follow me. Alright, so we've replaced plus 7 here with plus 2x and plus 5x. So we have 4 items here. So to factorize them, we're going to take them in twos. So we have, the first group is x squared plus 2x, and then the second group is plus 5x plus 10. So what do we do from here? We will look for the common item in x squared and also in 2x. Now if you consider the number, mind you, there is an invisible 1 in front of x squared. The coefficient of x squared here is 1. So we know that 1 is common between 1 and 2. So we take 1 out. Take 1 out. Then x is common between x squared and x. So we have x. So we know that 1x is a common item between x squared and 2x. So if we take it out, if we take x from x squared, we'll be left with x, of course, and then if we take x from 2x, we'll be left with 2. So we are done. We move to this second group. Between 5 and 10, we know that plus 5 is common. So if we take plus 5 from 5x, we'll be left with x, and if we take plus 5 from 10, we'll be left with 2. Now the common term here and here is x plus 2, and what you have left here is x, what you have left here is plus 5. So this is our answer. We've been able to factorize x squared plus 7x plus 10 to give us x plus 2 multiplied by x plus 5. Alright, so we look at the second example, which is 2x squared plus 7x plus 3. Now, like I said earlier, the first thing we do is to identify our constants. A, if you compare this expression with the general form of a quadratic expression, A is 2 plus 2, B is plus 7, and C is plus 3. Now, after identifying what our constants are, we proceed to factorizing. So now, we know that the first thing we are trying to achieve is to get two numbers that can be used to replace plus 7 here. Yes, we're trying to get two numbers that we can use to replace plus 7. And then we know that those two numbers should be such that when we multiply them, we should get a number that gives us the product of AC, and when we add them, we should get a number that gives us B. Okay, so what is AC? What number are we looking for here? AC, A is plus 2, C is plus 3. So plus 2 times plus 3 will give us plus 6. So we're looking for two numbers that we can multiply to give plus 6, and that we can also add to give B, which is plus 7. So those two numbers, we should be able to multiply them to give plus 6, and we should also be able to multiply those two numbers to give plus 7. So what are those two numbers? How do we find them? So like I said, we look for the multiples of 6. Multiples of 6 that we know are, the multiples of 6 that we know are 6 and 1, then 2 and 3. We know that if we multiply 6 and 1, we're going to get 6. And also that if we multiply 2 and 3, we're going to get 6. But then we need to choose one out of these two. Which one satisfies this criteria and also satisfies this criteria? Let's take the first one for instance, which is 6 and 1. Yes, 6 and 1, if you multiply 6 by 1, you're going to get 6, right? But is there any way we can add 6 to 1 to get 7? How can we add 6 to 1 to get 7? If it's plus 6 here and plus 1 here, we know that by the time we add plus 6 to plus 1, we're going to get plus 7. So we check it here. If we multiply plus 6 by plus 1, are we going to get plus 6? Yes. So 6 and 1 plus 6 and plus 1 satisfies these two criteria. So we don't really need to consider this since we already have two numbers that satisfy both. So now we replace plus 7 with those two numbers. Alright, so we've replaced plus 7 with plus 6 and plus 1. We see that instead of having 2x squared plus 7x plus 3, we have 2x squared plus 6x plus x plus 3. Now, after replacing 7x with plus 6x and plus 1x, we can now group them in twos. So we're looking for the common term between this one and this one, so we can group them, and we're also looking for the common term between this and this, so we can group them. So now, looking at 2x squared plus 6x, let's consider the numbers 2 and 6. What is common between 2 and 6? 2 is common, right? What is common between x squared and x? X is common, so write x. So 2x is common between 2x squared and 6x. So if we factorize 2x from 2x squared, we are going to be left with x. And then if we factorize 2x from 6x, we are going to be left with 3. That's it for that. And then we come here. What is common between 1 and 3? Obviously 1 is common. So if we factorize 1 from x, we will have x left. Factorize 1 from 3, we will have 3 left. So we have x plus 3. Take this 2x, take this plus 1. Yes, and that's it. We've been able to factorize 2x squared plus 7x plus 3 easily. Alright, so we look at the third example quickly, which is x squared minus 11x plus 30. Now we know that the first thing we do is to write out our constants, right? So we're going to write them out now. So our a is 1, our b is minus 11, and our c is plus 30. Now the next thing to do is to split minus 11 into two numbers that we can multiply to give AC, and that we can add to give B, like this. Yes, so those two numbers, we should be able to multiply them to give a number here, which is the product of AC, and we should also be able to add those two numbers to give B here. Now AC is A times C, which is plus 1 times plus 30, which is plus 30. So we're looking for two numbers that we can multiply to give plus 30, and we're looking for two numbers that we can add to give minus 11. Now what are the multiples of 30? The multiples of 30 that we know are 30 and 1, right? So we also know 2 and 15. We also know 3 and 10. We also know 5 and 6. So we're going to be considering these four pairs: 30 and 1, 2 and 15, 3 and 10, 5 and 6. We want to see which of these pairs will fit correctly into these boxes, these four boxes. Alright, so let's consider 30 and 1. Yes, 30 times 1 will give us 30, but there's no way we can add or subtract 30 to 1 that can ever give us 11. So we know automatically that it cannot be this pair. Let's look at the second pair, 2 and 15. Yes, 2 times 15 will give us 30, but there's no way we can add or subtract 2 and 15. There's no addition or subtraction we can do to 2 and 15 to get 11. So it's out of the consideration. Let's also look at 3 and 10. Is there any way we can add 3 to 10 or 10 to 3 to give us 11? No. And then we look at 5 and 6. Is there a way we can add 5 to 6 to give us 11? Yes. How? B is minus 11, so we're going to take that minus into consideration, right? So the only way we can add 5 to 6 to get minus 11 is when 5 here is minus, 6 here is also minus. So we know that if 5 here is minus And if 6 here is also minus, we know that it will satisfy this condition. Minus 5 plus minus 6 will give us minus 11. And if we check it, we'll see that minus 5, put it here, times minus 6 will also give us plus 30. So the two numbers we're actually looking for are minus 5 and minus 6. So we go ahead to substitute minus 5 and minus 6 into this place, which is by replacing minus 11 with minus 5 and minus 6. Alright, so we've replaced minus 11 with minus 5 and also with minus 6. So we have, instead of having x squared minus 11x plus 30, we now have x squared minus 5x minus 6x plus 30. So now we can now factorize by grouping them in twos. So the first thing we do is to take these first two, factorize them, and take this second two and factorize them. Alright, so what's common between x squared and 5x is x. X is common. If we take x from x squared, we'll be left with x. If we take x from minus 5x, we'll be left with minus 5. Okay? Yes. So what's common between minus 6 and 30 is minus 6. Alright? If you take minus 6 from minus 6x, we'll be left with x. And if you take minus 6 from plus 30, we'll be left with minus 5. And then we can see that x minus 5 is common. We take that out. Then we are left with x minus 6. Yes. So we've been able to factorize x squared minus 11x plus 30.